Bismillahirrahmanirrahim. Uh, First of all, uh, I want to explain the purpose of this video. This video is based on the course of the Skyfi Lab that I have done, and I exercised and I did a complete project uh, done by done by me, and I learned and I practiced all this, and I learned this all from the Skyfi Lab, from the structure analysis and design the course of two software. One is SAP 2000, one is ETAB software. So this is my ETAB software submission work. I'm just showing this in video because of to submit my work and I get certificate from the Skyfi Lab. So I'm very glad to have this course, and I finally found that in internet, and I enrolled in that, and I learned many things in the perfect way with step by step, and I noted down all the steps from them, from the videos, and their teaching method. Everything is always awesome. This is very perfect, and I love it. This work is perfect work they have done, and for the students and for the learners, they want to learn something, so they can easily learn many things in a very short duration of a videos, not more than 10 minutes. It is exactly a maximum video, the maximum limit of the video is 10 minutes. So I'm just coming here to explain my project. It is a project of G plus 23 tall building. So this is the plan view of this building, and this is the 3D view. In this model, I have defined sections, materials like M40 HYSP 415 mild 250. So this is the type of material we have defined. After that, I defined frame section for this tall building. Before starting the work, I have defined column three number of columns, C 500 into 500, and C 550 into 550, C 600 into 600. This three column, and I have defined, and this is three beam that I have defined. At the end, is defined one beam auto select. So that is when you choose this option, it is going to select an auto beam based on the span length, and based on the load applied on that beam, based on the moment, the pressure moment, these things all there, considering all the things, and they're selecting from this above three. They're selecting the best suitable option for themselves, for your building, for tall building designing and analysis. There at the end, when I came with when I finished the design, so there was a box showing that your building is going to be filled in two frame, in two elements, structural element, that was two column. So for that, I defined one column for 650 into 650 with this size. So by that, so I passed finally with the building design of the G plus 23. This was the frame section that I defined, and after that I defined the slab section also of 150 mm. So applied to this building, and now I'm coming to the explain how this building was designed, planned, first modeled. Now this building, this is this total, this is the plan of the building, but not overall plan from the bottom to top. It is going to change. It has a similar story concept, like from the 1 to 9th, first story to 9th story, there will be a similar story again. From let me check, from the 9th story uh, 9th story to story 14, there will be this kind of plan for the same stories, and from story 15 till 19, uh, we have this plan with similar stories from 15 to 19. And when you're going the top like 20, so this plan is going to change by this way. So this will be the plan for the top 3 4 stories, like from 20 to 23. So this will be the plan for last top 3 4 stories. So it was the similar story option, similar story concept that we, when you are defining the load, when you are assigning the load, assigning the loads at the time. Now it's not going because I have done analysis and design, so it is locked. So I'm not going to unlock it. I have some detailing. I need to take the detail, reinforcement detailing. So uh, when we assigned, when we wanted to assign the loads on slab and beam and column, on beam and cladding. So at the time, in cladding, so the time we were selecting the similar stories option. That was the for similar stories. Suppose we were staying in this plan. So if this plan is for is going to be for uh, from story 15 to story 19. So all the load you are applying for this plan will be applied to the same way to all similar plan stories. Now with this concept we went for all building load assigning. After that we defined the load pattern for wind load, live load, wind load, and for wind load we select Bangalore, and based on the modification we select from based on the IS code 875. We select wind speed, current category, structure class, all these things, and we put it here, and we modified a wind load for this building for cladding, from external wall cladding. Then we applied dead load and live load for slab and like that. So after that we analyze the building, and then um, we were taking for design. First we just picked that for design which code we need to have. So we first picked that design code. It should be 456 2000. So we were selected that. Uh, After selecting that, so we went for uh, designing. So start designing. I mean, after design this, or when the design over, when the design over, then it gives some message of some correction. So after doing the design from here, concrete frame design, and from here the start design slash check, it will process the design process procedure, and at the end it will give if there is an error, or wants to give a higher element, or the element that you have not uh, defined but it required a higher element, a higher section, then it will give a message of failure of 2 elements, so many elements. It's how many elements that they will show you how much elements are there to fail. So for that you again need to go for defining, and then define the section for that, and then analyze this, and again design. So the same process when they are going to design these things. This we have designed this all building with all dead load, live load, cladding load, wind load applied on the fourth side of this building, and finally we come with a successful design of this complete reinforcement with the perfect design. So this was a video for submission of my work to the Skyfi Lab